in developing operating systems, and as such, he is familiar with building large systems and what goes into that. But he loves finding bugs automatically now. His group remains really strong in that arena. And there's a couple of areas that he's been playing around with in the last couple of years. One is in the realm of statistical analysis, and looking at the code itself to infer behaviors from the code and infer from the code what should be true about the code. You can use that not only to find more types of defects without necessarily understanding the rules in the code, but you can also use that, and he has, to rank defects and to try to guess which defects are more important than other defects. Another area that he's working on is a little bit more of a traditionally rigorous approach to finding defects in code and proving properties about code, and that's in the arena of model checking. And he's done some work comparing static analysis work with the model checking work. He found that model checking might provide a more rigorous analysis, but in general it's actually much, much harder, both computationally as well as results-wise. It's much more difficult to produce results. Static analysis still provides a lot more results, but he's working on that problem as well. And one of the things he's been doing most recently is to try to automatically generate concrete inputs to programs that, as he would say, rolls up real code. And what that work was trying to do is to use static analysis concepts to, in essence, determine not only where the bug is in the code, but what kind of inputs you have to feed the program so that you could actually observe that bug as it's causing a problem in your code. And of course, these activities that tie together defects that you find on with source code analysis, if you can tie that to something tangible that the developer can run and see crash in their system, that only reinforces the reality of these issues that the static tool is finding, and it brings it a little bit closer to home when they can actually experience the bug themselves.
What opportunities do you see for being able to tie static source code analysis with the runtime or the real-time environments of embedded systems?
There's definitely a lot of potential for runtime tools that mesh well with static analysis tools. I think it's one of the potential benefits, as I just mentioned, is if you can observe certain things about the runtime and tie those back into the static analysis realm. For example, you have a test suite, and if you had a tool that could observe your entire test suite and then map that back to the paths of code that the static analysis was analyzing, so you could pinpoint the cases that the static analysis identified, and say, for example, when it found a bug statically, tell you to go look at test case 37, because that's where you should expect to see some bad ramifications. Again, it's about trying to make sure that all the static analysis results are actionable, trying to make sure that the developers understand which are the highest priority issues to find. And so I think there is opportunity to work with dynamic tools that are keeping track of what's going on at runtime to inform static analysis. Now, there's challenges as well, especially when it comes to the different execution environments that people tend to operate under. The benefit of source code analysis is that you're operating at the source code level, C, C++, Java, etc. When you start talking about object code and runtime tools, then suddenly what also matters is the execution target platform. And so, of course, there are many, many different architectures under which products run, especially in the embedded space. And so it does, in some sense, limit the ability to be very broad with the technology. It has to be specific to each type of target architecture. So that is one of the challenges in going that way.
On another note, how would you describe the state of the static source code analysis industry? Do you think there's still more evangelization to be done, or do you think it's now accepted within the development community, or where do you see it lying between those two?
Well, I definitely think we've made a lot of progress in the last couple of years, but I still think we're in an evangelism mode. I think there's a lot of learning to be done, a lot of re-education around what is really possible with these technologies. Lit came out almost 30 years ago, and I would say that most developers still think that's about as good as it gets. with source code analysis. They're not necessarily in touch with the latest research techniques in developing scalable static source code analysis to find real defects. And that's part of what we're out there doing, why we do these types of webinars, why I travel around the world giving various talks, is to really try to educate people as to what is available from this type of technology.
Earlier you mentioned the use of Linux against which this Coverity tool was run. How would you describe the relationship between Coverity and the open source community?
Yeah, that's a great question. So as some of the listeners may know, back in March we launched a site called scan.coverity.com, and that was really just the next step for us in our relationship with the open source community. We've been analyzing Linux since the year 2000 with the first versions of our technology at Stanford, and have continued that relationship by trying out our new technologies on various open source packages and giving those results to the various maintainers for validation, and so that they can fix those issues. And by launching the site that we did in March as part of our work with Stanford at Symantec under a Department of Homeland Security contract, we were able to formalize that and put up a site that every night could scan the open source packages on the site for defects, and it acts as a test bed for us where we can try out our new ideas for source code analysis, and it acts as a benefit to the community. It's been very well received. In fact, we have almost 1,000 developers who have registered for accounts and have accounts into those databases, and over 5,000 defects have been fixed, not examined, not reported. That's 5,000 defects fixed as a result of this project in these open source packages. So I think our relationship with open source is very healthy, as is our relationship with our commercial customer base, in that everybody recognizes that this technology is there to help, and it's there to help you make your quality much higher in the software. So maybe one more question, Gordon, and then we'll turn it over to the audience. Okay.
Well, I think a good segue. How would you compare the open source software compared to the proprietary developed software, since you're getting insight to both sides of the coin?
Great question, and some of you may actually have seen an opinion piece that I had in Business Week Online a couple of weeks ago that addressed this exact question. And I think overall it's difficult to compare them for some reasons, in that you're not always comparing the same types of applications in the open source realm and the commercial realm. But that aside, if you look at the overall general trends, what you see is that open source tends to cluster together from an average defect density standpoint in a very above average sense. The number of defects we find in open source packages has a very relatively low variance compared to that of what we've seen in the proprietary world. Now, of course, we don't publish individual results in the proprietary case because that would make a lot of our customers unhappy. But in general, what we see is the variance is a lot bigger. You have some organizations who are very, very concerned with software quality, such as Eris, and they tend to fall on a very high quality end of the spectrum, where they have a very few amount of defects that we find. And then others that may be less concerned with quality have more issues. And so I think for the most mission-critical applications, you find that they outshine everybody, closed source and open source. But on average, you probably find that they don't remain as well because there is so much more variance. And I think the reason for that, there might be many reasons, but the reason is in the closed source world and proprietary, things are driven by